Welcome to the Basic Civil Engineering lecture series by Roy M. Thomas.
Hi everybody. Now we will see two important terms in concrete, very important terms. They are one, water cement ratio. Water cement ratio. Usually it is represented like this W/C. And the second term is workability. Workability. The first one, water cement ratio. The name itself gives the definition. Water cement ratio. What is meant by water cement ratio? The amount of water to the amount of cement by weight. That's all. That is called water cement ratio. What is the purpose of adding water to cement, or what are the functions of water in cement or concrete? There are mainly two functions. The first one is when you add water to cement or concrete, a chemical reaction will take place and lot of heat will be emitted. So, it is an exothermic reaction. So, that is the first purpose. Because of that reaction, cement or concrete become harder or stronger. At chemical reaction, in a single word we can say hydration. Hydration. So, what is hydration? That is the chemical reaction taking place with the cement and water. For that purpose, water is required. Second purpose or second function of water is lubrication of aggregate. Lubrication of aggregate. When we discuss grading of aggregate, what is grading of aggregate? To make an economical concrete, there should be different sizes of coarse aggregate, different sizes of fine aggregate, and the voids are filled by cement and water. There comes the second function. What will lubricate the gaps and to lubricate the aggregates, and the gaps will be filled by cement. So, these are the two functions of water in concrete or cement. Hydration, that is the chemical reaction, and lubrication of aggregate. So, when you add water to cement, more and more the strength will decrease. So, we can represent the compressive strength and the water cement ratio. So, if you draw, it will be approximately hyperbolic like this. So, if you decrease the water content, water cement ratio, strength will increase, strength will increase. If you decrease the water cement ratio, strength will increase. If you increase the water content, strength will decrease. So, this is the relationship between the compressive strength and water cement ratio. It will be approximately hyperbolic in shape, hyperbolic in shape. So, usually this water cement ratio varies from 0.4 to 0.6. It may depends upon the site condition. This can be, again it can be increase or decrease, that is depends upon. Usually the ratio is between 0.4 to 0.6. So, what is the advantage of increasing water? Disadvantage we have seen, strength will decrease, but there is one advantage. If you increase the water content, the concrete will become more and more easy to work. So, as far as workers are concerned, it will be easy if the water content is more. There comes the second term, that is workability. So, naturally if the water content is more, it will be easy for the workers to mix, easy for the workers to place. Okay. So, they will try to increase the quantity of water, but the drawback is strength will decrease. So, second term workability, the exact definition goes like this. Workability means it is the ease or easiness, with which the concrete is prepared. First you have to prepare, transported, you have to transport, then you have to place in the proper place without losing its homogeneity. Without losing its homogeneity means water should not come out from concrete, cement should not come out from concrete, aggregate should not come out from concrete. So, separation of material should not be happen there. So, if like that, if you can place concrete safely, that term is called workability. Ease with which the concrete is prepared, transported, placed in the proper place without losing its homogeneity. How you can say, or how you can test whether the concrete is workable, or how you can test whether the added quantity of water is sufficient or not? As I have already mentioned, the laborers, the workers, they will try to increase the quantity of water because they want to finish the work earlier. Usually for concreting and all, the payment will be based on the quantity of work completed, or if they complete the concreting, they can leave the place. So, they will try to increase the quantity of water. As a civil engineer or as an engineer, you have to give instruction to reduce the quantity of water, but it should be within the limit. So, how to check up whether the added quantity of water is correct or not? There are two tests to check up this. Test for workability. The first test is called slump cone test. And the second test is called compaction factor test. The first test, that is carried out with the help of a cone that is called slump cone with a standard size. 10 centimeter diameter at the top view. This is the top view, 10 centimeter, and 20 centimeter diameter at the bottom. This is the bottom opening, 20 centimeter. This is 10 centimeter and bottom diameter 20 centimeter, and the height of the cone is 30 centimeter, which is having a platform with a stand and a scale. This is a simple arrangement of the test apparatus. So, this is the cone, scale and stand. So, this is the slump cone, 10 centimeter diameter at the top, 20 centimeter diameter at the bottom, and 30 centimeter height with the two handles for the lifting purpose. So, procedure is like this: prepare the concrete, mix cement, sand, aggregate and water. How much quantity of water? You can assume, or you can take the water cement ratio as say 0.4 or 0.5 or 0.6, whatever it is. Prepare the concrete, mix it properly, then divide into 4 parts. Okay. Then take the first portion and put it inside the slump cone, put it inside, first portion. Then compact it means take a 6 mm diameter rod, approximately this diameter, and to the convenient length, say 1 meter length, and do it like this. This is called compaction, to remove the voids, gaps. Then take the second portion, again say put it inside, compact it 25 times. Take the third part, put it inside, compact it 25 times. Take the final portion, put it inside, compact it and strike off level. And lift the cone vertically without disturbing the concrete. Lift it slowly like this. Lift it without disturbing the concrete. What may happen? The concrete will subside. So, when you lift the cone, the shape of the concrete may be like this. Assume this was the platform, stand, assume this was the initial position of the cone. When you lift the cone, concrete may attain a shape like this. Okay, when you remove the cone. Now, with the help of this scale, you can bring down the scale and measure what is this height. That is the height from the top of the cone to the top of the subsided concrete. What is this height? Bring down the scale and measure what is this height. This height is called the slump of the concrete, slump in millimeters. And for normal concreting works, this value should be between 80 to 150 millimeters, 80 to 150 millimeters. Suppose when you do this experiment, if you are getting a reading which is less than 80 mm, what it means? Added quantity of water is more or less. If it is less than 80 means added quantity of water is less. So, increase instead of 0.4, say go to 0.5 water cement ratio or 0.6 water cement ratio. Or if you are getting a reading greater than 150 mm, reduce the quantity of water and repeat it. So, if you are getting a reading in between 80 to 150 mm for normal works, depends upon the work, slump may be different. For normal concreting work, slump should be between 80 to 150 mm. This is the procedure. So, prepare the concrete, divide into 4, take each portion, put it inside, compact it 25 times, fill it fully, lift the cone, measure the subsided height of the concrete. There are some advantages for this test, some disadvantages for this test. Advantages are there, disadvantages are there. What is the advantage? Advantage. What is the advantage? This is the advantage. What is the advantage? It is portable and suitable for site use. So, wherever is your site, you can take this apparatus to the site, and there itself randomly you can check out whether the added quantity of water is correct or not. So, advantage, it is compact and suitable for site use. And procedure is very simple, just fill it and lift the cone. So, second advantage is simple procedure. So, compact, suitable for site use, and it is simple. Disadvantages. What is the diameter here? It is 10 centimeters. So, what is the disadvantage? What is the size of aggregate? Size of aggregate, it can be say 5 mm, it can be 10 mm, it can be 100 mm. So, it is not suitable for larger sizes of aggregate because the diameter is only 10 centimeters. Not suitable for larger sizes of aggregate. And second disadvantage is not suitable for wet concrete. So, what is mean by wet concrete? If the added quantity of water is little more, that is called wet concrete. So, for wet concrete, once you lift the cone, the concrete may attain a shape like this. So, it will not be possible to measure the slump. There will be confusion where to measure, how to measure. So, these are the two disadvantages: not suitable for large size aggregate, not suitable for wet concrete. Advantages: it is simple, compact, suitable for site use. Disadvantages: not suitable for large size aggregate, not suitable for wet concrete. To overcome these two difficulties, these two disadvantages, there comes the second test, that is compaction factor test. Compaction factor test, second test, compaction factor test. The apparatus consists of two hoppers and a cylinder at the bottom with a stand. This hopper is fitted to the stand. This is also fitted to the stand, having opening here, door at the bottom, door, here also one door. So, this is top hopper, this is second hopper or middle hopper, and cylinder at the bottom. So, this is apparatus, this is called compaction factor test apparatus, two hoppers and cylinder. Volume or size of these three hoppers are same, volume same capacity. So, procedure is like this: prepare the concrete, mix cement, sand, aggregate and water. Again we can assume some water cement ratio and prepare the concrete. Take one portion and fill it fully in the top hopper, Prepare sufficient quantity of concrete, take one portion, fill it fully in the top hopper. Open the door. What may happen? The concrete will come to the middle hopper. Now, the concrete is in the second hopper. Now, open the door. What may happen? The concrete will come to the cylinder. Take that weight. You can take out the cylinder and the concrete and take that weight. That weight is called partially compacted weight of concrete, say W1 kilogram. Now, remove the concrete from the cylinder, throw it away, cylinder, empty cylinder. Now, initially sufficient quantity of concrete is prepared, only half portion or sufficient quantity is taken to fill up fully in the top hopper, remaining is there. Divide that into 4 and take one portion and fill it in the same way as we did it in the slump contest. Compact it 25 times, take the second portion, compact it 25 times, take the third portion, fill it, compact it 25 times, take the final portion, fill it and compact it 25 times, track of the level. Take this weight, that is cylinder and compacted concrete, that is called fully compacted weight of concrete, fully compacted weight of concrete, say W 2 kilograms. So, one is partially compacted weight, second one is fully compacted weight. Now, find out the ratio W 1 divided by W 2, that is partially compacted weight divided by fully compacted weight. That ratio is called compaction factor, compaction factor CF, compaction factor CF. What will be that value? That value will be always less than 1, because W 2 is always more than W 1, because second step we are filling it by giving compaction. So, that quantity is more, and the recommended value is between 0.85 to 0.95 for normal concreting work. So, if you are getting a reading which is greater than 0.95, change the water cement ratio and do it once again. So, that is the procedure. So, prepare the concrete, take sufficient quantity, fill it at the top hopper, open the door, it will come to the middle hopper, open the door, it will come to the bottom cylinder, take that weight, partially compacted weight of concrete, remove the concrete and fill the cylinder by concrete giving compaction, take that weight, that is called fully compacted weight, find out the ratio partially compacted weight divided by fully compacted weight, the recommended value is 0.85 to 0.95. Here also there are some advantages and disadvantages. What are the advantages? To overcome the difficulty of slump contest, as I told you, compaction factor test. So, the advantages are suitable for smaller and larger sizes of aggregate, suitable for dry and wet concrete, wet and dry concrete, suitable for smaller and larger size of aggregate, suitable for wet and dry concrete. Disadvantages, it is not compact and not suitable for site use, not suitable, not compact, not suitable for site use. So, this is a laboratory experiment. So, these are the two tests for workability. So, one test is field test, another test is lab test. So, sometimes in the examination they may ask, describe the lab test for concrete workability, describe the field test for workability of concrete. Field test, slump contest, lab test, compaction factor test. So, now we have seen the water cement ratio and workability, two important terms. Water cement ratio, it is the amount of water to the amount of cement by weight. The relationship between the water cement ratio and the compressive strength, which can be represented with the help of a graph, that the shape of the graph will be hyperbolic. And the purposes of water in concrete, first purpose hydration, second purpose lubrication of aggregate. And second term is workability, ease with which the concrete is prepared, transported, placed without losing its homogeneity. The test for workability, first test, slump cone test, which is carried out with the help of a slump cone. Prepare the concrete, divide into 4 parts, and each part should be filled by giving compaction. After filling, lift it, measure the subsided height of the concrete. Recommended value is 80 to 150 mm. Advantages, it is simple, compact, suitable for site use. Disadvantages, not suitable for larger sizes of aggregate, not suitable for wet concrete. Second test is compaction factor test. The apparatus consists of 2 hopper and 1 cylinder. Prepare the concrete, take sufficient quantity, fill it in the top hopper, open the door, it will come to the second hopper, open the door, it will come to the bottom cylinder. Take that weight, that is called partially compacted weight. Remove the concrete and fill the cylinder with the same identical mix of concrete prepared initially by giving compaction. Take that weight, that is called fully compacted weight, and find the ratio partially compacted weight divided by fully compacted weight. Recommended value is 0.85 to 0.95. Advantages: suitable for smaller as well as larger size of aggregate, suitable for wet as well as dry concrete. And disadvantages: not compact, not suitable for site use. Thank you.